All right, it's time. So I want to do some more examples of non-regular languages, showing that a language is not regular by using derivatives. Remember the big theorem from last time is if L has infinitely many derivatives, then L is non-regular. So if you have a language and you want to show that it's not regular, the way to do that is by showing how you can take the derivative in different ways and get infinitely many different results for taking that various derivatives. So like a simple example, we did several examples last time, but they were all kind of the same, or at least very similar to one another. Today I want to do some more slightly more exotic, more interesting ones. But one, like the ones we did last time, would have been something like a, b to the n, a to the n. The way to go about this is to explain how you can take different derivatives and get different answers in sort of infinitely many different ways. So I'm going to say, you write this like a little proof, but the proofs are really pretty formulaic. You have to have a good idea, but as far as proofs goes, these are not hard proofs. Anyway, I'm going to say let di be. The idea is you write down some kind of generic derivative formula, which is going to give you a different answer for all the different various i's, and that means you'll get infinitely many different derivatives. Anybody have a solution or a suggestion here? Remember what we did last time? Yeah?
Just A and then B to the end, but like no grouping. Would that work?
Yeah, something like that. You should use I in there somewhere. Yeah, A, B to the I is a good idea. So this will take the ideas, or this will take the strings in my original language and cancel off of the beginning of them. It will cancel off that first A followed by some number of B's, where that number of B's is different for each of these DI's. All right? So that's this derivative of L. And what would that look like when I write this as a language? You would say, what does it look like after you cancel those things at the beginning? Yeah?
A, B to the n minus I, A to the n.
B to the n minus I, A to the n. Right. No A on the front because you canceled it off from the front. Great. The language as it used to exist is this, but I'm canceling the first A plus some of the B's at the beginning. And now it looks like this. B to the n minus I, followed by A to the n. And the point of this is that those sets are always going to be different for various values of I, right? So one way I could say, so I'm going to say these DI are all different. Since, for example, in DI we have, this is the same kind of thing that I wrote in every example last time. We have I fewer B's than A's, right? So like in D1, there's one fewer B than there are A's. In D2, there are 2 fewer B's. And those are different from each other, right? They're all different. So we have infinitely many derivatives. So there are infinitely many derivatives. So L is non-regular. All right. Yes?
So, but we need to give like actual examples, or can we literally just say like there's I fewer, so it doesn't work?
I would say what I wrote there is acceptable. I'm not exactly sure what else you could say. I mean, you could say something like, for instance, D1 contains like BAA, whereas D2 contains BAAA. You could say that if you want. But really, it's hard to say that in a complete way because these are individually sets. Like, it's not like D1 is just equal to BAA. It's a whole set of things where you have this many fewer B's than A's. Yeah?
Do we have to make mention of the first A, like in that
No, because really all I'm talking about are these sets di, which are they have this form. That first a is kind of already gone by the time you start talking about di. Yeah. Okay, so this is what I consider like an easy example, or at least it's pretty formulaic. It's very much the same as the ones we did last time. I want to talk today about some less formulaic ones, or ones that, I mean, they're formulaic in their own way, but they're not exactly like this, at least. How about, oh, and maybe before I say another example, just to sort of build up our intuition about this, when I look at that, eventually I hope that we'll all get to a point where I could just show you a language and say, does this look regular or not to you? When I look at this, I feel like this is not regular, and the reason is because of this repeated n up here. That's really the issue here. So I'm just going to mention that. The real issue comes from the reuse of the n, the same n, in like a to the n, b to the n, right? Like a to the n, b to the n is the classic example of the non-regular language. What makes it non-regular at some informal level is the fact that you use that same n both times, versus like a to the n, b to the m is regular, right? What makes it non-regular is the fact that the second part is in some way restricted by what happened in the first part. And it's not possible for a DFA to kind of, if you think about how a DFA would have to do that, we'd have to like read through all these A's and then somehow remember how many A's there were before it reads through all these B's. And that's not really possible because the number of A's could be anything, and the DFA is not capable of potentially remembering how many that could be. Whereas this is regular because by the time you get to this part, you don't care what that part was anymore. And so there is no issue about remembering anything forever. All right? The reuse of the n is a real issue there. That's why when I look at this, I mean, it's not exactly the same, but it still has this n both times, which immediately makes me suspicious of that as being regular. All right, let's try some slightly more complicated. How about a to the n, b to the 2n? All right? For the same reason, you should immediately look at that and say that's probably not regular because I used the n both times. Although I didn't exactly, I mean, it's a 2n the second time. Does that really matter? Well, no, it doesn't really. But all right, let's try and just do the same thing. So this is also not regular. Let's try the same argument. So I'm going to let di be, what should I take the derivative this time? Something involving the I. Yeah?
A to the I.
Yeah, a to the I, because that's the part on the front. I want to cancel off part of the front, leaving the other part uncancelled. Of L, right? And when I write this out as a language, it's going to say a to the n minus I, b to the 2n. And are those all different sets from one another as I vary the I? Well, yeah, they are. I mean, when I is 1, what you see here is there's one less a than there is. Usually I would say something like there's one fewer a than there are b's, although that's not exactly true in this case. But you should still say something like that. So in di, can anybody say some simple description of the situation here? It's not really there's one less I, or I less A's than B's. It's something, yeah?
Oh, I lost it.
Okay. It's not exactly easy to say in a few words.
I less A than half B.
Yeah, so he said something about half of the B's. That's how I would say this. That's basically what I said on paper. Yeah, I said in di the number of A's is I less than half the number of B's, right? Anyway, once you say that, I think it is clear that the di's are all different for various i's. So for D1, that number of a's is 1 less than half the number of b's. For D2, it's 2 less than half the number of b's. And those are all different steps. So I would just write the same thing I write at the end every time. These di are all different. Different. So L is non-regular. All right, great. How about, let's try one. All right, this one is a little interesting. I don't know if you felt like that one was interesting. Here's another one. I think this one is also interesting, maybe for different reasons. A to the m, b to the n, a to the n. And banana. All right, so here the m there is different from the n, but I still have two matching n's, which should feel kind of like non-regular to you. How are we going to take our derivatives in this case to make the usual thing happen? There's an obvious answer that's not quite right, which I expected somebody to say. You want to say it anyway? I'm not saying you're going to be wrong.
I was thinking, yeah, it would be d to the a to the m, b to the n minus I.
Oh, okay.
Like, I was thinking you take all the front a's off, since that's not related,
That's right.
and then you just do the same thing.
Yeah, what's going through your mind, I hope, is like the real action is right there, and I just want to kind of bypass this. And so I'm going to take my derivative, just wipe this out entirely, and then go on with the b's. Maybe I'll write this in red, because this actually is not quite right. Something like that, right? He said n minus I, which you could do, but this is just as good. So that then the derivative of that, so of L, and the derivative of that would be b to the n minus I, a to the n. And then I would say the same business that I always say. I'm still writing this in red. I don't know if you can tell the colors on the screen here. This is not quite right, though. Does anybody feel a certain kind of way about this? There's something that's not really correct about this. Actually, this sort of, that part is correct. It has to do with this thing here, taking derivative with respect to a to the m, b to the I. Yeah?
Can you not have like an undefined number of something and a derivative like that a to the m?
Yeah, the problem is this m here. This a to the m, I'm going to say, is bogus here. Since my question would be, what exactly is m? And the answer is, well, it's kind of a variable. Like m could be any natural number. So this doesn't really make sense. I mean, I is like a specific number, which is, there's a D1, there's a D2, there's a D3, so that's what I is. But what is M? It's kind of nothing. So a to the m is bogus here, since m is really like a variable, right? Which could be any natural number. That's why this is what I said is probably, I hope that this is what you had in mind, but this is actually not allowed because of that. So
It's just right there.
a to the I. This is an interesting idea. So he said A-I-B-I, is that what you meant? Just a to the I? This will not work, I don't think. Thinking here. I hadn't expected somebody to say this. So what would you get? I think that this is going to be wrong, but what would you get for the derivative if you did derivative with respect to a to the I? This a to the m could be anything, so it's going to cancel some of these a's, and some will remain, or maybe you cancel all of them, and then you'll get nothing left over. I think what you get is basically this, right? Are those all different? this is the issue. They're not, actually these are all the same, because m can be anything, and so this is just a to some anything. And for different values of I, they're all the same. These are all the same set. Actually, this is one of those sort of counterintuitive cases where it looks like they're all different as sets, but in fact they're all the same, because m can be anything. Another idea?
Yeah, I don't know. I was gonna say, because like we can't have m, but we have to get rid of the front part. Could we just say a b to the I, but then that would still be a to the m.
A b to the I. This is actually closer to what I had in mind. A b to the I. Actually, a b to the I will work. I'm gonna say instead here, and this is the same idea, but a little cleaner if you do it this way. Here's the true answer. This will seem wrong at first, but it's actually right. Sometimes it seems right, but it's wrong. This is like my body says yes, but my mind says no, or something. I don't know. B to the I. Is that really what I meant? Yes, that is really what I meant. Sorry, I scrolled. The original language is A to the M, B to the N, A to the N. All right? B to the I. Can you believe it? Anyone want to tell me what is the answer when you do this derivative? So, what you should think is, isn't the answer going to be the empty set? Because these words, or these strings all begin with A's, and when you're taking derivative with respect to B, they go away, right? Is that what you're going to say?
I don't know, I was thinking maybe you just put the A back or something, like it was some kind of special case or something. But I guess it doesn't.
Think about what I just said. I said these strings all begin with a bunch of A's. Actually, that's not quite true. Some of them use m equals 0, right? So, when you take this derivative, everything that did begin with an A goes away. All that's left are the ones which actually did begin with B and were B to the N, A to the N. And so, the result here is B to the N minus I, A to the N. This is kind of tricky. Yeah.
So, the reason that works is because, compared to like before, when you couldn't do that if it didn't start with it, is because you couldn't have 0 of something, you had to start with something. Like, because here you could have 0 A's, whereas like in the other examples that we did, like yesterday, you had to have at least like 1 in the beginning. For example, like
maybe like this very first one,
yeah.
It definitely has an A at the beginning. Yeah.
Yes, like because you need to have at least 1 A. That's why just doing the D would work, right?
Yeah. Like in this example, if you had just done B to the I, you get the empty set. Because these all begin with A's. Here, this is kind of a cute little cheat or something. We're taking the derivative with respect to B. Almost everything in here will go away entirely, but there will remain the ones which originally started with no A's. I'm going to try to sort of explain that. So in L, most strings, in L meaning the original one, most strings start with A. But for those where the m equals 0, we take B to the I and get something like B to the N minus I called A to the N. So this derivative, it kills most of the language entirely, but the part that remains are all going to be different for all the same reasons that we said in all of the other groups, all right? So this was just a little sort of parenthetical explanation of why this derivative actually equals that, even though there were extra A's. The point is, sometimes there were not extra A's at the beginning, and those ones will fall through and give you this. Okay, so anyway, I can write my usual conclusion here, right? Then DI has, this is very much like all the other examples. I fewer B's than A's, and so DI are all different. Right? The end. Tricky, a little tricky there. let's try some more. I got some more tricky ones, and then I have some for you to try. How about, this one is inspired by, of course, everybody's favorite, the sort of OG example of the non-regulars is a to the n, b to the n. This is inspired by that, but slightly different. This is all x such that the number of a's in x equals the number of b's in x. So it's kind of like a to the n, b to the n, but they're not all sort of sorted out. They may be distributed around the string, but you have the same number of a's as there are b's. The derivative a to the I? Yeah, actually this is the way to do it. So I'm going to say let di equal the derivative with respect to a to the I. This is going to work in a similar way as before. You might say, well, there's no guarantee that these strings begin with a at all. And I would say that's correct, but some of them do begin with a bunch of a's one after another. And those are the ones that are going to remain after you take this derivative. Just like this one up here. Even though it looks like these words start with a's, some of them don't start with any a's, and you can take derivatives with b. So these strings, some of them actually did begin with a to the I. And so, can you say what the result is after you've taken the derivative of these? So it's like you consider these strings where the a's equal the b's, the number of a's is the same as the number of b's. You consider only those ones which begin with a to the I, which some of them do. You take those a to the i's away. Can you say then what do these strings look like? Yes.
The numbers of a's in x equals the numbers of b's in x minus I.
Yes. Okay. Yeah, I always get confused about which way around they go, but yeah, that's right, what he said. The number of a's.
Could we rewrite it as a to the n, b to the n?
No, because it may not. That has all the a's first, followed by all the b's. But these can be in any order. Yeah, that's what makes it harder. The number of a's in x equals number of b's in x minus I, right? I think that's what he said. Or you could write it the other way around. The number of a's plus I equals the number of b's. That's equivalent. Do you have a question? I saw it before. Good?
Can you re-explain this one?
Yeah, so it seems strange to take this derivative because these strings, they don't even begin with a's. But actually some of them do. There are some of these strings which have where this string actually looks like a to the I followed by some other stuff. And then in taking this derivative, we are canceling off the a to the I part. And then here I'm trying to describe what's left over. Well, the other stuff here, apparently, like if it used to be the same number of a's and b's, I've just taken away I of them, so now there are fewer a's than there are b's. To the tune of that right there, the number of a's is I fewer than the number of b's. Yeah. So I will conclude with some formulaic words, like I said in all the other examples. So in di, number of a's is I fewer than the number of b's, and that means that these are all different. So di are all different. A little tricky. All right. You've got to choose your derivatives wisely. I got two more, and then I have some for you all to try. How about this one's? Oh, sorry, I got three more. One is just a variation of that one. How about this one? All x such that the number of a's in x is less than number of b's in x. This one actually you can do almost exactly the same thing. You're going to take the derivative with respect to a to the I. Actually, you could have also used b to the I. It doesn't matter. When you take the derivative with respect to a to the I, you are imagining only those ones which have a stack of a's at the front, and you take that away. You could have done it with b's, it doesn't matter. But I'm going to say that dib derivative with respect to a to the I of L, which is How would I write what that ends up being? You take those ones which did begin with a bunch of A's, you get rid of those A's, and then what's left over?
Number of A's in X is less than number of B's in X minus 1.
Yeah, right. Number of A's in X is less than number of B's in X minus I. All right. So in DI, I'm going to try to say something like I said before. Before I said, like in this example, it was an equal sign. It was an equal sign. So I said the number of A's is I fewer than the number of B's. I would say this way, I would say something like number of A's is less than, well, I end up just writing the same thing as this again, right? It's the number, it's less than I fewer than the number of B's. Is that even grammatical? Maybe I'll just not write it. Since I'm gonna end up just writing the same thing again. How about this? So DI are all different. I want to try to be clear about this just because, as we've seen before, sometimes the sets can look different, but they're actually the same. But in a formula like this, when the I is like part of an inequality or an equation, they're definitely going to be different every time. Yeah.
Did you say at least I fewer?
The number of A's is at least I fewer. Yeah, something like that would work. Yeah, I like that. The number of A's is at least I fewer. Yeah, I always confuse myself. Is that at least I or at most I or whatever? But I think that's right. Yeah, great. Okay, now I got two that are a little different, and then I have some for you all to try, as I said. Let's try. How about this? X squared. This is the language of all squares. This is also non-regular, even though it looks quite different from all those other examples. So this involves things like all squares. That is strings which are squares. That would be something like A, B, A, B, right? It's like one thing followed by the same thing again. That's what a square looks like. And I feel like this is going to be non-regular, kind of for the same vague reasons like A to the n, B to the n. Like you have to read through, if you were going to do this on a DFA, you'd have to read through this list of letters, and then somehow remember what they all were so that you could read check that they were exactly the same letters again the second time around, which is not clear that a DFA could really do that. Remember all the first part, because you don't, the first part could be arbitrarily long. So anyway, I feel like that's going to be non-regular. We're going to do a similar trick. Again, the issue in terms of deciding which derivatives to use is you have no idea what this string begins with, right? And so we're going to do a similar trick to what we've been doing in the past couple examples. Like here, we didn't know what it began with. We just use A to the I. And that kind of forces these to begin with A to the I. Some of them do begin with A to the I. We do the same trick here, right? We don't know what x squared begins with, but I mean, some of them will begin with A to the I. So hopefully that's going to do some good here. So I'm going to say let BI be derivative with respect to A to the I of L. And now, what is the set that's left over? When you consider only those which began with A to the I, you take those A to the I's away, what can you say about the rest? What is left? I would suggest, as a way of thinking this through, I'll make this sort of parenthetical. When x squared actually begins with A to the I, well, I'm going to write it this way. When x begins with A to the I, then it's like, x would be something like A to the I times y, or that's something else. And so x squared would look like A to the I y, A to the I y, right? Is that a question, or are you going to tell me what?
Yeah, just So you can write derivative of x with respect to a to the I.
Yeah.
Is x.
Is x?
Like derivative of x with respect to a to the I. And
I
then
think
x.
it means where you wrote L.
So just like divide x squared. It's x.
You wrote X.
I don't understand. Are you telling me what to write right here?
Yeah.
Say it again.
Derivative of x.
Derivative of x, okay. Derivative
By
a to the I, yeah,
x. Just x.
okay.
And then x after I don't know how to write that. Multiplied by x.
Like that?
Yeah.
Okay. Yeah, I guess so.
I mean that.
What if x starts with B? Then it's just x in x.
Yes, if x starts with b, you get,
X.
yeah. I don't think it's helpful to write something like that. I would,
Is it?
yeah, I'm not sure I follow the idea behind it. I found myself wondering about like product rules or something when you start with that. I don't want to think about that. Don't say 2x, certainly. That's the derivative of x squared. I would like to encourage you to think of it this way. Maybe you're thinking of it a totally different way and I'm not following. But did you have another?
Is f a I x with x in
A to the I x?
a to the I x.
X, a to the I x. Yeah, I was going to write it. This is what I was trying to get at down there. I'm going to write it with y's. But. The reason is because of this sort of what I said in the brackets here. What I'm imagining here is we're only considering the things in L which really did start with a to the I, and then we're canceling that a to the I off of them. Now, if x really does begin with a to the I, then you can write it as this: x is a to the I times y. And that means that x squared would be a to the I y, a to the I y. And then, so what do you get when you take the derivative of this x squared with respect to a to the I? The a to the I goes away at the beginning, and you end up with just y, a to the I, y, like that. Alright, so what this is, I hope that that's clear. And so what it is d to the I is strings with, I would describe this as something like I, A's in the middle. And then it has a thing at the front, followed by I, A's, followed by that same thing that was on the front, repeated again. Alright? But for the purposes of what I'm saying here, what's important to notice is that that thing in the middle is a to the power I. And that's why these are different every time. So D1 has one a in the middle. D2 has two a's in the middle. D3 has three a's in the middle. So those are all going to be different sets. Di is strings with I, a's in the middle. And for various different values of I, those are different sets. So these are all different. Exclamation mark. Alright. This is the same general trick where this x might not start with a to the I, but we imagine that it did, and then you can say, well, if the x did really start with a to the I, then you can figure out what the rest of it would look like. And then that tells you what the format of the DI is. Alright, I got one more like this, and then you guys can try some. And of course, we'll have more on the homework. We are going to have homework, back on our usual homework schedule starting this weekend. How about this? L equals x followed by the reverse of x. That's what x to the r means. So x, that xr means the reverse of x. So for example, ABAAB reverse means BAABA. You just write it in the opposite order. X followed by the reverse of x. These are kind of, not exactly, but kind of like palindrome strings. Really, a palindrome string is one in which x equals the reverse of x. That also is a non-regular language, a set of all palindromes, but this is similar. The reverse of x. All right, I want to do a similar trick to what we just did before. So I'm going to take di. Again, when you don't know what this starts with, it could start with anything. You just make it start with a to the i's. That's the idea. Derivative with respect to a to the I of L. On the side here, I want to imagine, what if x really did start with a to the I? Then I'll write it as something like x equals a to the I times y, right? And then what does that look like if you do x followed by x reversed and then cancel off the a i's at the beginning?
It would just be y, API. Right? X.
Yes, almost. He said y, a to the I. There's a little something you got to put in there. But what you want to think about is what happens in x reversed. That would be a to the I, x followed by a to the I, sorry, not x, y. A to the I, y reversed, which is a to the I, y. And then what? What do you get when you reverse a to the I followed by y, the reverse of that? Y a to the I. That's not quite right.
Y reversing?
Yeah, y reversed a to the I. How do you like that? Think about that. It's true. Y reversed, because y could be a long string. Alright, and anyway, that means when you take this thing and take its derivative with respect to a to the I, that a to the I goes away. What remains is y reversed a to the I. Right? But either way, those di's are all different because they end with a to the I. And so if you use different values for I, you get different sets. Alright, so I will just say that in some words. di ends with a to the I, so these are all different. Right, all the strings in d1 end with a to the 1. All the strings in d2 end with a squared, etc. Alright. These are some of the tricks you may have to do these derivative problems. Any questions about that one? I got some for you to try. How about, so some of these will be easier, some of them will be fancy like these last ones. In each case, show that this is not regular. That one. That one, and the second one there is x followed by x bar, where x is, these are strings of zeros and ones, and the bar means not, meaning you swap, a 0 turns into a 1 and a 1 turns into a 0. Bitwise not, if you like. Alright, see what you think. I'll give you a few moments. We got 10 minutes remaining, and we can chat about some of them. I put them roughly in increasing order of complexity. free to talk to your friends. If they're here.
I don't know, it's weird because it's like the second.
Yeah, actually you don't want that because then these, they just go together a little bit. It's a, I would say leave it out. And it leaves it as they there can be a and no, yeah, it's better because then here they separate anything and those come together into a big block of these.
So it doesn't really matter. There's no thing like the important thing is that the number of bees are different.
Yes, and there needs to be a in the middle, because then if there's no a in the middle, there's no a in the middle part that you do the beginning versus the end.
Okay.
Yeah, beginning, beginning, yeah, very good. Okay.
Yeah.
Yeah. Very good.
Well, for the second one, isn't this, I don't think this is right though, because this is the, yeah. Okay, so then what did you do?
Yeah, they are just, starting with, but they are. Good? Over here, you should still say it's exactly the same. All right. Okay, yeah. So all you go from here to here, remove some pages. It doesn't actually change this.
Condition stays there.
Yes.
Also, the way to like to
Because it's the same set again, and you just remove some days. Condition others. I'm gonna write down my answers here. Maybe we'll talk about the second two. All right, so the first one I think is the easiest of them. You should do the derivative with respect to bi. Then it looks like this. And now I have a block of b's at the beginning and a block of b's at the end. And you can say that there are I fewer b's at the beginning than there are b's at the end. And so the di are all different. As I was walking around, I saw some people try to also cancel the a. Like you could do bia, which will also cancel the a in the middle in some cases, but actually you don't want to cancel the a in the middle. Don't do that. If you also cancel the a in the middle, then this collapses into just one big block of b's, and then you can't say this thing which I said here, which is fewer b's at the beginning versus fewer b's at the end. Because if it all gathers into one lump of b's, then there's no such thing as the ones at the beginning as being different from the ones at the end. It's important to preserve them, segregate them like that. All right. How about the next one? The next one is not a much harder idea, but it's kind of confusing to write, I think. This is a to the n, b to the m, where 2n is less than m. All right? So here, oh, by the way, I wanted to say, as I was walking around, I saw some amount of, some differing amounts of how much stuff you wrote. Some people only wrote that much. This is not good enough. You got to actually explain the argument. All right. Now, we're all friends here, and you're trying to do all the problems. So I get it if that's all you want to write. But when you're writing your homework, so when you're writing an answer on a test or a quiz or something, I want to see the voids. All right. Some people, I don't know. Some people are like allergic to writing actual words in a math class. Don't be that way. Mathematics is done in the English language, in language at least. You can. It's not always done in English, I suppose, but in some kind of language. Don't just write a bunch of equations and make me figure out what you're trying to explain. You're trying to demonstrate that there are infinitely many different derivatives. So say it. Okay. Anyway, this one I'm gonna say let di be the derivative with respect to a to the I of L, which is, in this example, it cancels off some i's at the beginning of those things. I saw some controversy about, should I also change this over here, subtract I from this n over there? The answer is no. I mean, all you're doing is taking this set, strings which look like that, where there's a relationship between n and m, and you're taking away some of the a's, like this. But they still have the same relationship between n and m. The original n and m still have that same relationship. All right? Question about that? No. So can you say in words what these sets look like? This is kind of complicated to explain in words. This is a set in which there are, I don't know. I saw at least one person say it nicely as I was walking around. What would you say?
I don't know if this sounds very good. What I said is there's at least less than half A's and B's. Like, so you have to be
Okay.
like
Said it too fast.
Half, and you have less than half. Like you have to put like the half is like you have to at least be less than that.
At least less than half.
At least double b's and
You got to say something about I, because the whole point is that you're going to get something different for every different value of I. Another idea?
Where I less A's is less than half the B's.
Okay, I like this. I fewer A's is less than half the B's. I don't know if that makes sense. This is difficult to say in words about this. One way that I think makes this easier, some people were trying to change around this formula. You could rewrite this, but use, instead of n minus I, change it to, I'll call this now like L. I'm doing like a variable substitution, where L is like this. L is n minus I. Right?
A to the L, B to the N, whereas 2L less than N minus 2I.
I think that's the same. if you did some kind of.
You use L and N. What's L and what's N?
Oh, it should say plus here. L, I'm doing L equals N minus I. So yeah, that should be a plus. Yeah. This to me looks easier to describe. Now I can just say it's some number of L's.
But if you write like that, it's A to the L, B, N, and then 2N plus I less than N. It doesn't say what L is and what N is and how they relate to each other.
Yes, I agree. Oh yeah, it should be L plus I over here. Yeah, thank you. I changed N minus I to L, which means I have to change N to L plus I, right? So this is some number of A's followed by some number of B's, and there's this relationship between those things. And you can tell this has to be different for different values of I, because this condition will be different for different
Instead of
values.
having to write like word for word, you just say you have L and N, that's like this fine.
Yeah, that's fine. Yeah.
I mean, it's also a language. It's just a more precise form.
Yeah, right. So, yeah, I think what he suggested was something like the number of A's and number of B's satisfy, you know, this formula, right? 2L plus I less than N. And those formulas will be different depending on what I is. So these are different sets. Good. Another question?
Yeah, I just wanted to ask if this would be valid. DI has I fewer A's than double the number of B's.
Maybe at least I fewer A's than something like that is correct. Although I'm not sure exactly. It's hard to be convinced that you're saying it exactly correctly. Yeah.
I have another thing where I just changed it, so I changed it to like I fewer A's where I is less than half of the number of B's.
Something like that, although I'm not sure that was a real sentence.
I don't know.
Yeah. I would say, to be honest, when I'm like grading the homework or something, I would probably give you credit for any of these attempts. I mean, I want to see some evidence that you're trying to explain to me what that means and why they're different for every I. These are, the English language kind of breaks down a little bit when we try to describe these in words. So I will be generous with the credit if that's what you're concerned about. All right. We went a few minutes early. Maybe the next time we will just go over that last one.